Hello and welcome to the computer learning class by Accelerate Computer Systems. My name is Arun and I will be your trainer today. We have already learned about subnetting and IPv4 IP address. Although most of the computers still have the IPv4 IP address, IPv6 is slowly catching up. And very soon you will start seeing IPv6 IP address on computers. And this is why it is important that you understand how you can create subnetworks with IPv6 IP address. As a network administrator, it is essential. We know that IPv addresses are 128 bits long and are completely different than IPv4, which are just 32 bits long. Let us first understand what IPv6 address is and how it works. Let's have a look at an IPv6 address. The first thing to note is that the IPv6 is written in hexadecimal. If you have not watched the video on hexadecimal, I would definitely recommend you to do that. There are 8 segments with 4 hexadecimal digits separated by colon. Each of the hexadecimal numbers that you see is expressed in 4 bits. So this means that this too, it is expressed in 4 binary bits. This also means that every segment separated by colon is 16 bits long. Why 4 bits for every hexadecimal number, you might ask? Let us take 4 bits and have a look at the place value. Do you remember how we get the place values in binary? From right to left, we start with 2 to the power of 0. Then we go on to 2 to the power of 1, 2 to the power of 2, etc. etc. When you calculate it, the place values are 1, 2, 4, 8, 16, 32, etc. Now in our case, we have the place values 1, 2, 4 and 8 because we have only 4 bits. All right. If we add all the place values, that is all these numbers, we get 15. Considering that 0 is also a number included in hexadecimal, we get 16 numbers in total. And in hexadecimal, the numbers range from 0 to 15, which is 16 in total, including the 0. And this is the reason why each hexadecimal number is equal to 4 bits in binary. Now, if we convert all the hexadecimal numbers into binary, every segment will have 16 bits because each segment has 4 hexadecimal number and each hexadecimal number is equivalent to 4 bits. In total, we will have 128 bits in IPv6 IP address. IPv6 IP address is really long and it can be daunting to remember to write this entire IP address. Look at this. And this is why there are certain exemptions while writing it. Let's have a look at it next. Now, here's an IPv6 IP address that we saw. That's 2001 colon 0db8 colon 0000 colon 0000 colon 02AA colon 0000 colon 0000 colon 9C50. That's long. The designers of IPv6 IP address, they knew that remembering or even writing a 128-bit IP can be a challenging task for anyone. To make it easy to write IPv6 IP address, they provision some exemptions for the user or writing the different way of writing. We'll have a look at it. If any of the sections has leading zeros, these can be removed. Keep in mind that only leading zeros can be removed. Now, in our case, we have leading zeros in 0db8 and 02AA. Let's get rid of these zeros. So you see, we removed the zeros. Okay. Now the IP address is slightly shorter. The next exemption is that if there are all zeros in one section, we can write just 1 0. Here we can see that there are 4 segments, 1, 2, 3, 4, and they have all zeros. We can just put 1 0 for each, thus further shortening the IP address. There. All right. Now we have 4 segments with just 1 0 in them. If the system looks at these, it knows that the segment consists only of the zeros and it adds the necessary zeros. Now the IP address can be further reduced in size. This is done by combining consecutive segments with just zeros and replacing these by a double colon. In our case, we have two consecutive segments with just zeros. While using this exemption, the rule is that if there are more than two segments with consecutive zeros, only one can be changed. So we have 1 and 2, but we cannot do for both. We have to do just for one. So in our case, we have these consecutive segments with zeros before and after 2AA. Let us change the one before 2AA. Right. Finally, we get the IP address as 2001 colon DB8 colon 2AA colon 0 colon 0 colon 9C50. This is much better, right? Keep in mind that you will use double colon irrespective of the number of consecutive segments with 0. In our case, there were only two consecutive segments with zeros. Even if there were 3 or 4, we would just have used only colon only twice. You might ask, then how would the system know how many segments are there with zeros? Well, the system knows that there are 8 segments in an IPv6 IP address. When it looks at an IP address with double colon, it knows that this section contains more than one segment with all zeros. To find out the number of segments there, it just counts the visible segments. In our case, the visible segments are 6. And then we know that there are 8 segments in total in an IP address, IPv6. This shows that there are only 2 consecutive segments with zeros hidden behind this double colon. So you see that we had a very long IPv6 IP address, and we managed to shorten it by using rules. Even after shortening, the IP address may still be very long when compared to IPv4, but this still is very much better than writing the entire IP address. All right, let us have a look at how an IPv6 address is assigned and which organizations are involved in the process. The organization that manages the overall internet is called IANA, which stands for Internet Assigned Numbers Authority. It is the primary organization that manages IP addressing autonomous system allocation, to name a few. IANA works with regional internet registries in specific regions that help IANA in managing number allocations. I found this very good image on the website of ARIN. This world map shows different regions managed by different regional internet registries. You can find out the relevant organization with the help of the color. So you can see which organization manages which part. For example, Afrinic, right here, it manages the African region. ARIN, it manages North America. EPNIC, it manages South Asia and Australia. All right. Let us take an example of ARIN, which manages the North America region and which is assigned the IPv block 2001::16 by IANA. Normally there is a specific range of IPs which can be assigned. We are taking this IP address as just an example. Let me show you the IP allocation hierarchy using a graph. You can see here we have two graphs, and this shows the hierarchy as to how the IPs are assigned, starting from IANA on top and up to the end user in both. On the left, you can see the graph from EPNIC, which manages IP address allocation in Asia Pacific and Australia region. And on the right, we have the graph from ARIN, which manages IP allocation in the North American region. You can note the difference in hierarchy in both. In both graphs, the common entities are IANA, 5 regional internet registries, local internet registries, and end users. Note that the local internet registries can also be the internet service provider or ISPs. I wanted to show you the graphs to explain that there is no fixed hierarchy of how the IP address blocks will be assigned. Now let us go back to our example and see how ARIN or ARIN will assign IPv6 blocks and how a company uses the given IP block to its employees. We are back to the graph, which shows different regions covered by different regional internet registries. In our example, we took IPv6 address block 2001::16. which is assigned to ARIN by IANA. Why is that 16, you might ask? Remember that the IPv6 is written in hexadecimal, and each number here is equivalent to 4 bits in binary, which makes it 16 because it has 4 hexadecimal numbers and each number is 4 bits long. Okay, now that ARIN has the block 2001 : 16, it cannot change 2001. It can only create subsegments and allocate it to others. Let us just say that ARIN provides the block 2001 : 0db8 : 32 to one of the local internet registries or the internet service providers. Keep in mind that ARIN can assign the block to the ISPs or LIRs only in the North American region, because ARIN manages only this region, this particular region. All right. When the ISPs have this block, they further create blocks and give it to companies or end users depending on their size. Let's assume that the ISP has provided the block 2001 : 0db8 : 1111 : 48 to a company that has 10,000 employees. Okay, now that the company, which is ABC Corp, has the IP block of 2001 : 0db8 : 48, let us have a look at the IP address now. We know that the IPv6 IP address is 128 bits long and contains 8 segments of hexadecimal numbers each segment. Okay. Now, out of this 128 bits, we received a 48-bit block from the internet service provider, which is right here. Let me add the remaining bits as zeros to make it a 128-bit. All right. Here the company can use the next segment of 16 bits, this part, to create networks, and the remaining 64 bits can be used for the end hosts. 64 bits means that the company has the option to have these many hosts under one network. These are a lot many IPs. All right. So today we learn about IPv6 IP address. This was just a basic introduction so that you are familiar with it. In our next section, we will learn more about the features of IPv6 address and what types of IPv6 addresses are there. As a network administrator, it is imperative that you know about IPv6 address because this is the IP address of the future. Slowly, everybody is moving towards IPv6, and with the advent of Internet of Things, very soon you will start seeing IPv6 being used everywhere. At Accelerate Computer Systems, we work with students and startup companies in Canada by providing them with high performance and low cost computing devices to help them learn and grow. These Dell laptops that we sell start at just $400. These laptops, they come with at least Intel i5, at least 8 gigs of RAM, which can be easily upgraded to 16 or 32 gigs, option of hard drive or SSD, original Windows 10 or 11, 60 days warranty and optional 1-year warranty. If you would like to know more on how you can save on your next laptop purchase, do send us an email on the email that is flashing on the screen. Thank you so much for learning with me today. If you have any questions or comments, I will be glad to answer those. I will see you in the next video with a very new topic. Until then, happy learning.